What we have in this system that we built is basically a mobile sensor platform. That platform is a mechanism by which we can take very frequent, repeated measurements of the properties of the plants growing beneath that platform.
We are observing a networked infomechanical system here at Toolik Lake, Alaska. I'll go ahead and describe to you what sensors we have on this. This is basically a sensor package that is extremely expandable and modifiable. This is called a PAR sensor, or a photosynthetically active radiation sensor. So it's measuring radiation coming from the sun that plants obviously utilize, hence the name photosynthetically active. We also have this thing here. This is called a green seeker. It's made by Trimble. And this measures what's called normalized difference vegetation index, or NDVI. This is basically a ratio of near-infrared energy to red, because plants are absorbing red and reflecting near-infrared. So it gives us an idea of plant productivity as well. This is a fiber optic here. This is actually going to a hyperspectral sensor. We have another one that's pointing at the ground, but this one's actually pointing at a reference surface. You can see here that is constantly reflecting all light, so that we know exactly how much is being reflected in terms of a reference, so that we can correct for changes in sky conditions, because we don't always have bright blue sunny skies during our whole run. Since I'm on the subject of the hyperspectral sensor, this is a fiber optic, basically your standard fiber optic that's allowing light to be passed through into the sensor that is inside the enclosure here. I can actually show you that if you'd like to see it. This is made by a company called Ocean Optics. It's based out of Florida as well. This is called a jazz spectrometer. So we have two fiber optics. This is a 2-channel sensor. We have one looking at the reference and then one looking at the surface. Here we have a Campbell Scientific CR3000 data logger, which most of our sensors are wired to. The hyperspectral sensor that I just mentioned is actually run by a miniature PC computer that we mount on board that allows for data to be streamed into there via a USB cable. Otherwise, all of these instruments are run into this data logger, of which we can then retrieve the data from at a later date. Down underneath here, this bell-shaped thing is a Campbell Scientific sonic distance sensor. So when it's on, it makes a very small clicking sound, and so it's actually sending out acoustic signals down to the ground, and then it reads the difference of time, obviously, to measure the distance down to the sensor. So this gives us a couple of different pieces of information. This gives us an idea of how high our platform is off of the ground, as well as how high we are from the vegetation itself. This sensor gives us an idea of actual vegetative growth throughout the year. This tube here is encasing an infrared temperature sensor. This is made by Apogee Instruments. And as the name sounds, it's obviously looking at the surface temperature as our mobile platform moves along the transect. And then lastly, we have a net radiometer. This is made by Kippen Zonen, and this is measuring both incoming and outgoing, both shortwave and longwave radiation. So these domes here are measuring our shortwave radiation in 180 degrees all the way from the top, and then there's another one on the bottom that's measuring the reflected shortwave radiation. And there's a little disc here that's measuring the long wave, or radiation coming from the sky. And there's another one on the bottom that's measuring emitted radiation from the Earth. We get the system up and running, and then we have a gearhead motor there that we flip on. That's it in motion, and it moves at about a speed of 3 centimeters per second. So it takes about 25 to 30 minutes to get from one end to the next. So our transect is about 50 meters long.
Purpose of this project is to examine long-term changes in the vegetation composition and the structure of tundra plants across the Arctic. We have 5 different sites that have these systems going. We have one here at Toolik, one just up the road at Imnaviet Creek, one in Atkasuk, Alaska, which is about 60 miles south of the coast, south of Barrow, Alaska, where our 4th site is in Alaska, and there's one in Thule, Greenland, which is a very high Arctic site. It's near the Air Force Base there. One of the things that these 50-meter transects do is they provide us with a baseline that other people could then use in the future, because we're making measurements that we don't know exactly how they're going to be used. We have a suite of sensors on our sensor platform, and it collects way more data than we can personally process. We collect the data, we post the data, they're there, they're going to be in a national archive, so 50 years from now, if somebody wants to come back, they can look at a 3D image 3D movie going across that transect. They could look at specific plants that are there over the years, over the days. That's the idea, is to establish a baseline of high resolution measurements.